Ever wonder why your phone heats up when charging?
This is due to resistance. As a current travels through a wire, electrons collide with the vibrating ions of the material called the lattice, resulting in energy from the current being dissipated as heat.
However, a superconductor experiences zero resistance and no energy loss, meaning if you were to apply a current to a superconducting circuit and remove the energy source, this current could theoretically last forever.
Superconductors also repel magnetic fields by creating their own equal and opposite magnetic field on the inside. Thus, if you place a small magnet on top of a superconductor, it will levitate.
So how do these superconductors work? Well, BCS theory offers insights on how one type of superconductor works, low-temperature superconductors.
When a low-temperature superconductor reaches a critical temperature, the material changes from its regular conducting state to its superconducting state. As electrons travel through a lattice, they attract positively charged ions around them. This creates a positive attraction around the electron that then attracts another electron, forming what is known as a Cooper pair. The force connecting the Cooper pairs is greater than the repulsive force between the electrons, and thus electrons as Cooper pairs travel as one. While individual electrons occupy different energy states, Cooper pairs occupy the same energy state. Think of this as a ladder. Individual electrons stay away from each other and occupy different rungs, but electrons as Cooper pairs hang out on the same rung. Because Cooper pairs all occupy the same state or rung, they travel together through the lattice. The unique thing about Cooper pairs is that they occupy the ground state or bottom rung, meaning there's no lower energy level for the electrons to occupy. Because of this, it's impossible for the current to lose energy, and minor interactions within the lattice do not result in the necessary change of energy to affect the superconducting state, hence zero resistance and zero energy loss. When the temperature of the material rises, lattice vibrations increase. This breaks up Cooper pairs and prompts electrons to transition to various energy states or rungs, resulting in the loss of superconductivity. Superconductors are cooled to reduce these vibrations.
While BCS theory doesn't explain how superconductors work at temperatures above 30 Kelvin, scientists are working to develop a high-temperature superconductor that could one day revolutionize energy transmission.